Hello, I'm Canchen, and today we'll have a shorter lecture talking about structs. So what we'll cover today are what are structs, how do we define them and instantiate them, and then how they interact with ownership. And then in the next lecture, we'll be going a little more in depth on how can we actually use structs. So today we're just going over the basics. And then if you're interested, the material in the Rust book that covers similar content is this chapter right here. So first off, let's talk a little bit about what are structs, right? And struct is short for structure, and structs are a composite type in that they hold multiple related values together. So they're a way to help you group your data, right? So some of you might be familiar with objects and object-oriented programming languages like Java, or if you've worked with like classes in C++, or structs exist in C++ as well, right? So you might be familiar with like the idea of we would want to group together related values into a single like object, right? And we've talked about tuples in the past, right? Where they're also a way that lets you group like many different data types together. And what's the difference between structs and tuples? It's that in a struct you can name each piece of data and give it like give each field like a name. But in tuples you could only access it with like the index, so like .0, .1. So structs are a way to help us like give more meaning and help us better group data together. So I've prepared a quick little demo here about how structs work. So we can start by talking about how do we define a struct, right? So the general like framework for how we make a struct is something like this, where we want to use the struct keyword to define a struct, and we'll specify each field of the struct with the name of the field followed by the type. So the way this works is here we say struct to say we're defining a struct, and then we'll put in the name of the struct. Here it's user, and then we have braces to tell like what is the content of the struct. And inside we have this field name. So this field is called active, and it's a bool. So it's like, is the user active on whatever service they're on or not? And username and email are both strings, and then sign in count is an int, right? So it's pretty similar to like how you would define like fields for a class in Java, right? It's just that in Java it's like private bool active, but here to be more consistent with Rust formatting, we have the field name first and then the type. So I think like defining structs is pretty simple and straightforward. So now let's go into looking at how we can instantiate structs, right? So here we have a function that's supposed to return a user. So here we have to do some work to create a user. And when we instantiate a struct, we want to specify a concrete value for each field. So here we see that user has 4 fields, and here we'll assign these 4 fields each a concrete value, right? So we'll give active true, we'll give username a new string, and we'll give email a new string, and we'll assign some value for the sign-in count. And it's very important that we have all the values here, right? So if we're missing a value, for example, let's delete the username, it'll throw an error. And if we run something like cargo check, it'll tell us, okay, we're missing username, right? Very helpful. And then the other thing to note is that the fields don't have to be in the same order that they're defined in the original struct. So I can mix up the ordering, and then there's no problems. Or you can cargo check, and it'll say no problems. Pretty cool. So that's how we want to instantiate an instance of our struct. Next, we'll talk about how to access the fields. So if you want to access the fields, we just use the dot notation. So we'll say like user.username or like user.email. And so that's like pretty straightforward, I think, and easy to understand. And the one thing to note here is that since look, here we're setting user.sign-in-count to be 68. We're modifying it from the original value. So we have to specify user as mute because variables are immutable by default, right? So if we delete this mute keyword, we'll get a complaint. And if we cargo check, it'll tell us we should set our user to mute in order to be able to change the value, right? So structs behave like primitive types in that they follow all this like rules about borrowing and ownership and mutability and stuff like that. Here we have a different function, and this shows a shorthand way to initialize a struct. So if a variable has the same name as the struct field, we don't need this name : value notation. We could just supply the variable. So instead of saying active colon something, we could just write active, right? And Rust will be smart and figure out that, okay, the active field of the struct is supposed to get this value, right? But if we change this to something else, like, I don't know, active bool, this won't work, and we'll have to specify it manually using something like that. So this is pretty handy in like functions or like constructors where you want to be, yeah, it's just like a little shorter, not as verbose. And then we'll show one last way of how we can initialize a struct. We can actually initialize a struct using the values of another struct. So the way we do that is we'll specify the fields we want, and then the remaining fields will be copied over from the other struct. So here we have first user, we've constructed a user, and let's say I want this same user but just active to be set to false, right? So what we could do is here we just set active to false, and then we say dot dot first user, and all the remaining values, the username, email, and sign-in count will be taken from the first user, right? The only thing to note is that here the values actually get moved from first user into other user. So if we try and do something like access these values, so what if we, let's say, we can let x be like first user dot username, right? We'll get an error because we've already moved username into other user, right? So if we maybe cargo check to show that this is indeed the problem, it'll tell us we've moved the value here, and then we're using the value after move, right? But there's some like things we can note is that we can still use this active field, right? Because it didn't get moved. Or in fact, we can still use the sign-in count. Why is this the case? Even though it did get like moved, right? It wasn't already supplied here. The reason is because sign-in count, again, it's an int, so it implements the copy trait. So it gets copied instead of moved, and we still like maintain ownership of this, right? Whereas for the string, the like value it's pointed at is now owned by other user. And then if we really wanted to use this username, what we can do is we can actually, if we supply, let's say, a different username, like let's say string from hello, we can see that because we've supplied a username here, username doesn't have to get moved from first user. And then finally, another solution might be, okay, we know for strings, if we wanted to clone the item, right, we don't have to lose ownership of it. So we can try .clone, but we'll see, actually it's complaining that we can't clone. And we can fix this using some shenanigans, which we'll go more in depth about in a future lecture when we talk about traits, right? But we just have to tell it that user has the ability to clone before it lets us use the clone function. And Rust can use a variety of different things to implement this clone trait. But for now, this isn't super relevant. But just know that when we use this sort of notation to initialize a struct, by copying values from a different struct, these copied fields get moved into the new struct. That's kind of the core point. Yeah, so that's pretty much all the content for this lecture. Some announcements is that homework 6 is released today on PriorityLearn, and it'll be due in a week. So thank you all for listening, and hope to see you soon.